Hello everyone. Today I am going to tell about difference of sets with examples. Solutions of question 9 to 12 from exercise 1.4 from Ncert class 11. If you take any two sets, the difference of those two sets is the set of all elements which belongs to the first set but not the second set. For example, if you take A and B are the sets, then the difference of A and B is the set of the elements which belongs to A but not B. That is, exclude common elements, that is A intersection B also. You have to exclude the common elements of these two elements from A elements. You have to write all the elements of A, but you have to exclude the elements of the common elements of A and B, that is A intersection B elements. Here the difference is denoted by the symbol minus, and that is A minus B. We can say as A minus B. For example, if you see here, in the A set, the elements are 2, 4, 6, 8, and in the B set, 6, 8, 10, 12. Here you have to, A minus B means you have to write only A set elements, excluding the common elements. Here the common elements are 6 and 8. These are A intersection B elements. So you have to exclude the common elements from A. So here A minus B is 2, 4. Only you have to write these two elements. And if you want to find the difference of B and A, that is B minus A, you have to write only B elements, excluding the common elements. So you have to write only 10, 12. This is B minus A. In the second example, if you see here, A, E, I, O, U, these are the elements of A set, and A, I, U are the elements of B set. So here A minus B, you have to write the elements of A, excluding the common elements. A, I, U are the common elements. So only E, O, these are the elements of A. And B minus A. So here B minus A, you have to write only B elements, excluding the common elements. If you take out all the common elements, those are A, I, U, there are no elements in B. Therefore, B minus A is an empty set, no elements in B. That is equal to an empty set symbol is this one. So you have to write this one. So here in this case, you can see here, if B is a subset of A, because all the elements of B are also in the A. So if B is subset of A, then we can write as B minus A is equal to the difference of B and A is equal to an empty set. Similarly, if A is a subset of B, then A minus B is an empty set. Now you can see how we can write A minus B and B minus A in set builder form. Here A minus B is equal to X such that X belongs to A and X does not belongs to B. So in this case, here X belongs to only A, but it does not belongs to B. That means you can exclude the common elements of these two also. And B minus A, X such that X belongs to B and X does not belongs to A. And how we can represent A minus B and B minus A by Venn diagram, you can see here. If, for example, if A is equal to 1, 2 and B is equal to 2, 3, 4, then A minus B is equal to, only you have to write A elements, which does not belongs to B elements. So 2 belongs to B also. So you have to write only 1 here. And B minus A, you have to take only B elements 2, 3, 4, but you have to exclude 2. So 3, 4. And A intersection B is, the common element here is only 2. So you have to write A intersection B is 2. Now you can show these three by using Venn diagram like this. This is a universal set. And here this is A set and this is B set. It contains all the elements, and here B set contains all the elements. But here A minus B only one, it contains only one element. That is 1. So you have to show here this one in this A minus B. This is A minus B and B minus A 3, 4. These are the elements. So you have to show this is B minus A. So excluding this part. This is A minus B. This is B minus A. And A intersection B. This is the common area for these two. So here this is common, that is in A intersection B, common element. So that is 2. Only you have to write 2 here. This part is A intersection B, this part is A minus B, this part is B minus A. And you can see here, A minus B, B minus A and A intersection B are disjoint sets. Because here, if you take any of these two sets, there are no common elements. You can see here A minus B and B minus C. If you intersect these two, there are no common elements. So if there are no common elements means empty set means those sets are called disjoint sets. So these two sets are disjoint. Again, these two sets are disjoint because here there are no common elements for any two sets. Now I am going to tell about symmetric difference of two sets. The symmetric difference of any two sets A and B is the set A minus B union B minus A. So once you find A minus B and B minus A, if you union those two sets, then that is called symmetric difference of two sets. So this is denoted by the difference, symmetric difference of A and B like this. And the symmetric difference of A and B is equal to, you can write as A minus B union B minus A. For example, if you see these examples, in the first set, A 2, 4, 6, 8 are the elements, and in B 6, 8, 10, 12, A minus B, we know that we have to write only A elements 2, 4, excluding the common elements or B elements. So 6, 8 you have to exclude, so 2, 4, and B minus A, similarly you can write 10, 12, and A. The symmetric difference of A and B is equal to, you have to union these two sets, A minus B and B minus A. So write 2, 4, 10, 12. These are the elements of symmetric difference of A and B. Similarly, if you see this example, here EVO and this is an empty set. So the symmetric difference of A and B is EVO. Similarly, if you see this set and here also 3, 4. So here if you observe all these sets, so here it does not contain the common elements. That means it does not contain A intersection B elements. So the symmetric difference does not contain the intersection of those two sets. And if you see second and third example, here B is subset of A. So if B is subset of A, then the symmetric difference of the two sets is equal to A minus B. You can see here this EVO and here also EVO. So the symmetric difference of A and B is equal to A minus B if B is subset of A. Similarly, in the third example, if A is subset of B, then the symmetric difference of A and B is equal to B minus A. See here, that is equal to B minus A. And if you write this in a set builder form, you can write like this: A, the symmetric difference of A and B is equal to X such that X does not belongs to A intersection B, because here it does not belongs to the common elements, that is A intersection B. And if we represent the symmetric difference of A and B by Venn diagram like this, if you take the two sets A and B, 1, 2 and 2, 3, 4, then A minus B only 1 because 2 is common, and B minus A only 3, 4, and A intersection B 2. So if you see here, this shaded portion, this one is the symmetric difference of A and B. That means A minus B union B minus A. Here the elements of A minus B, these are the elements of A minus B, and here the elements of B minus A. If you union these two, then you will get the symmetric difference of A and B. And this is excluding A intersection B. So you have to show like this. If you calculate the symmetric difference of A and B here, 1, 3, 4. Union these two, 1, 3, 4. Now I am going to tell the solutions of question 9 to 12 from exercise 1.4 from Ncert. This is 9th question. Here there are 4 sets are given. You have to find the difference of these two sets. See here, all the values you have to find. So for that, you have to write first the given sets here. These are the given sets A, B, C, D. And you have to find these values, A minus B, A minus C, A minus D, like that. First one, A minus B. If you see here, A, the elements, you have to write all the elements of A, excluding the elements of B. That means you have to take out the common elements. Here only 12 is the common element for A and B. So you have to exclude 12. Remaining all the elements you have to write here. See here 3, 6, 9, 15, 18, 21. This is A minus B. Similarly, A minus C, you have to write all the elements of A, excluding the elements of C, that is common elements. So you have to exclude 6, is the common and 12 is also common. So you have to exclude remaining all. You have to write in A minus C. Like that, you have to find all the values here. A minus D, B minus A. B minus A means you have to write B elements and excluding the common element only 12. So remaining are 4, 8, 16, 20. Like that, you have to find all the values here. Here D minus C. You have to find. Here there is only one element, B minus C. See here only one element, 8, B minus C, 4, 8, 12, 16. All elements are in C. So you have to write only one element, 20. So this is called singleton set. Like this, you have to find all these values. And next problem, question 10. Here there are two sets are given. X is equal to ABCD and Y is equal to FBDZ. You have to find these values, X minus Y minus X, X intersection Y. So first write the given sets here. The common elements are B and D here, C. And X minus Y, you have to write only X values, excluding Y values. Those are BD, common elements. So A minus Y here. AC. Here the elements are AC and Y minus X. Only write these elements FG, excluding BD. So FG and next one X intersection Y. Only common elements, those are BD. If you see all these sets, there are no common elements for these sets. So these sets are called disjoint sets. So if you intersect any two sets here, so you will get an empty set. So these sets are called disjoint sets. This is 11th problem. If R is a set of real numbers and Q is a set of rational numbers, then what is R minus Q? So here R is a set of real numbers. So we know that real numbers include the rational numbers as well as the irrational numbers. Irrational numbers means root 5, root 3, root 2, etc. And rational numbers are all the numbers, including natural numbers, whole numbers, and integers, everything. So it is in the form of P by Q. So all rational numbers and irrational, it includes all rational numbers and irrational numbers. So we know that the real numbers contain all rational and irrational numbers, that is Q and Q dash. Therefore, here R minus Q is equal to, here set of R is set of rational and irrational, minus Q is set of rational numbers. If you difference of these two sets is, if you take the common elements, those are rational numbers. So the remaining are only irrational numbers. You have to take out the common elements here. So because we are finding the difference here, so we have to take out the common numbers are rational numbers. So the remaining are irrational numbers in this set. So that is equal to irrational numbers, that is equal to Q dash. Irrational numbers we will denote as Q dash. Therefore, R minus Q is a set of irrational numbers. And next one is 12th one. State whether each of the following statement is true or false. Justify your answer. The first one is here, the elements of the first set are 2, 3, 4, 5 and second set 3, 6 are disjoint sets. We know that if you intersect these two sets, then you will get an empty set. That means no elements in that set. Then only those sets are called disjoint sets. So just check the first set here. So here intersection of these two sets is equal to 3. 3 is the common element. So 3 is an element here. So we are not getting any empty set here. So the sets are not disjoint sets. So it is a false statement. This statement is a false statement. And next one is, next set is AEIOU and ABCD are disjoint sets. You have to check the common elements here. A is the common element. So we are not getting here also an empty set. So the sets are not disjoint sets. Hence it is a false statement. Third one is 2, 6, 10, 14 and 3, 7, 11, 15. Check here any common elements. No, there are no common elements. So it is an empty set. So the sets are disjoint sets. Hence it is a true statement. Next one is 2, 6, 10 and 3, 7, 11. Here also no common elements. So it is an empty set. Therefore the sets are disjoint set. Hence, it is a true statement. Now, please do these practice questions. These are the answers.